For this next set of examples, we are to find dy dx at the given point given implicit functions. To find dy dx for implicit functions, the first step is to differentiate both sides of the equation. Now for this part, we will apply the product rule. So we have 2x, you copy 2x, and then differentiate with respect to x, e to the 5y, plus, copy e to the 5y, and then differentiate 2x. The derivative of 2x, so differentiate 2x. And then this is equal to the derivative with respect to x of 2. Now, this is equal to 2x. Now, the derivative of e to the 5y is e to the 5y. So that's e to the u. Again, the derivative with respect to the derivative of e to the u with respect to x using chain rule is e to the u du dx. So we have e to the u, that's 5y, times du dx. That means derivative of 5y. That is 5 dy dx. Plus e to the 5y times, and then you differentiate 2x. Derivative of 2x is 2. Equal to the derivative of 2, which is 0. Now, since in this problem here, we are to find dy dx evaluated at 1, 0, it would be best to plug in 1, 0 at the values of x and y at this point. So we'll go ahead and plug in 1 for x and 0 for y. And then from there, we solve dy dx. So when you plug in 1 for x, this becomes 2. So we have 2 times 1 e to the 0. 5 times 0 is 0 times 5 dy dx. Plus e to the 5 times 0 is 0 times 2 equal to 0. Then you simplify that. Now 2 times 1 is 2. Now e to the 0 is just equal to 1. So this will just be equal to 1. This is just also equal to 1. So we have 2 times 5. That gives us 10 dy dx. Plus 1 times 2, that is just 2. So plus 2 equal to 0. Then we can easily solve for dy dx from here. You transpose 2 to the other side of the equation. That gives you negative 2. Negative 2. And then since you still have 10 here, then you divide both sides by 10. So you have negative 2 over 10, and that is equal to negative 1/5. Second example, find dy dx in this expression here and evaluate it at the point 1e. So to find dy dx, we need to use implicit differentiation. So in this expression here, we are to use product rule since this is considered one factor and this is another. Again, if you have two variables being multiplied to each other, two different variables, you multiply to each other, you will use product rule. So the derivative here will be x, so copy x first, and then differentiate ln y with respect to x. Plus, so product rule, copy ln y, and then take the derivative of x. equal to the derivative with respect to x at 1. Now copy x and then take the derivative of ln y. Now since this variable here do not agree with this variable, that means we use chain rule. The derivative of ln u is 1 over u. So in this case, the derivative of ln y is 1 over y times the derivative of y with respect to x. So times dy dx plus ln y, and the derivative of x with respect to x is just 1. This is equal to 0. Derivative of 1 with respect to x is 0. Then next, you plug in 1e to the point here. So x is 1 and y is e. So this one becomes 1 over e. You replace x here by 1 and y by e. So 1 over e dy dx plus ln of e. Y is e. So ln e times 1. So you don't need to write that down. Equal to 0. Now ln e is just equal to 1. ln e is 1. So therefore, you have 1 over e dy dx plus 1 equal to 0. Then you can transpose this on the other side of the equation. That gives you 1 over e dy dx equal to negative 1. Then you multiply both sides by e to cancel e. So you multiply here by e and you do the same thing here too. So therefore dy dx is just equal to negative e. Now for the third example, we are also to use product rule. So we have x squared times the derivative with respect to x of e to the 1 minus y squared plus copy e to the 1 minus y squared times the derivative with respect to x of x squared. That is equal to the derivative with respect to x of 1, the derivative of the constant here. Then perform the differentiation. So you have x squared and then derivative of e to the 1 minus y squared. That is using the derivative of e to the u. The derivative of e to the u with respect to x is e to the u du dx. So this is just equal to e to the 1 minus y squared times du dx. That means derivative of u here, which is derivative of 1 is 0, and the derivative of negative y squared is negative 2y times dy dx plus e to the 1 minus y squared times the derivative of x squared, which is 2x. And that is equal to 0. Then next is to evaluate it at the point 1, 1. So you replace x by 1 and y by 1. Therefore, you have 1 squared. This is just 1 squared. And that becomes e. So 1 squared is 1. And e to the 1 minus 1 is e to the 0 times negative 2 times 1 is negative 2. And then you just copy dy dx here plus, again, this is 1 minus 1. So that's e to the 0 times 2 times 1. And that is equal to 0. Then you simplify it. So this is negative 2 dy dx is negative 2 dy dx plus e to the 0, which is just equal to 1, times 2 equal to 0. Then therefore dy dx is equal to, now you transpose 2 on the other side of the equation. You have negative 2 there. And then the 2 here, you will have, so you'll have negative 2 dy dx, and then you can just divide both sides by negative 2. So therefore, dy dx is just equal to negative 1.